Hello everyone, myself S.K. Arshad. I am currently studying BTech in the stream of Computer Science and Engineering at Srinivasa Ramanujan Institute of Technology, Anantapur. I am here to discuss recursion. Introduction to recursion. Recursion is a program technique where a function calls itself to solve a program. It often used to break down complex program into simpler and more manageable subprograms. Understanding recursion is crucial for solving problems in computer science and mathematics. How recursion works. A recursive function typically has two main components, the base case and recursive case. The base case provides a condition under which the function will stop calling itself. It's nothing but a condition in for loop, which we can use. We can compare it with where we have to stop the recursive function. It can select. The recursive function involves function calling itself with modified parameters to approach the base case and the recursive case. The base case prevents the infinite recursion which can lead to stack overflow errors. It's essential to define the base case clearly to ensure the function terminates correctly. It can break the terminative function at, at a certain point at the point we need. The recursive case usually involves in solving smaller instant of the original program. Advantages of recursion. Recursion can lead to cleaner and more understandable code in some scenarios. It simplifies the implementation of algorithm for problems that have a neutral recursive structure. Recursive solution can often be shorter than their iterative counterparts, enhancing readability. Disadvantages. Recursive function can lead to higher memory consumption due to the call stack. This may be less effective compared to iterative solution for certain problems. Debugging recursive function can be more complicated due to their self-referential nature. Here we can use recursive function for smaller programs and smaller things. We can't use for bigger things because it characteristics doesn't help us effectively on working big problems and big things. It significance is essential in solving smaller problems and smaller things. Here we have a sample program for recursion. Here we initialized the header file and we declared integers, the variables n and I. Here we call the here we declare the function. Here this is int means the return type and the Fibonacci is the name of the function and int is the data type of the variable we use it in the function. We use the printf to display the enter the number of terms and we take the integer that number of terms we needed. Again we print the Fibonacci series. Here we call the function. When we call the function, the cursor moves to the subprogram where the recursion takes place. Here this as usual, here int is the return data type and Fibonacci is the function name and here int is the data type and n is the variable we can take from the main function. If n is equal to 1, we can get the value 1 and else if also n is equal to 0, we can take a return value 1. If the both conditions fail, again it enters into Fibonacci function, the main function we need in this. Here the Fibonacci n minus 1 plus Fibonacci n minus 2. Here the function takes place and again calls the recursive function. Here we for suppose we can take n is equal to 5. Here we get 4 and here we get 3. Again if n is equal to 3, that it's take input to the main again the recursive function. Again it's come to and again we can get more recursive functions until if the function n is equal to 1 or n is equal to 0 will be executed. If once it all the functions moves on and the recursive stops and we get a good return value and the suitable return value, it adds all the functions and it takes all the return values and moves to function where we can call the function with its variable function or with recursive function name and the variable. And again we use for loop to display the Fibonacci series. using recursive function. Here is the sample output program by using the above program. Here we display the enter of number of terms, and we as usually we enter the number of terms we need. Here we can see Fibonacci series. Here we can observe the first term is 0 and 1. The Fibonacci series means by adding the previous two terms and giving the sum of these two numbers to the third term. Here we can see it works correctly. Here 0 plus 1 is equal to 1 and 2 plus 3 is equal to 5. Again 5 plus 3 is equal to 13 and goes. It goes on until the number of terms we entered. Here recursive function uses effectively for the smaller problems, and hence recursive is very useful in our day-to-day life, and it makes our work simpler and easier and more effective and manageable. Thank you for giving this opportunity.